We would like to find the image of the line real part of z equals pi over 6 under the map w equals sine z. So this is x equals pi over 6. So that is a vertical line at pi over 6 on the x-axis in the z-plane. So that's our domain here. We would like to know the image of this vertical line under the mapping sine z. So let's consider sine z. Sine of z is sine of x plus iy. And then using the formula for the sine of the sum, we have the sine of x times the cosine of iy plus the cosine of x times the sine of iy. And then we have to recall the cosine of iy and the sine of iy. The cosine of iy is the hyperbolic cosine of y. And the sine of iy is I times the hyperbolic sine of y. So sine x cosine iy is cosh y, and cosine x sine iy is the hyperbolic sine of y times I. So this is the complex sine function, the sine of z, sine of the real part, hyperbolic cosine of the imaginary part, etc. So in our situation, we have x equals pi over 6. So if we take advantage of that here, x equals pi over 6, that means that w, which is the sine of z, is equal to the sine of x, that's the sine of pi over 6, times the hyperbolic cosine of y. Y can be anything. And then plus I times the cosine of pi over 6, and that's 30 degrees also, times the hyperbolic sine of y. So the sine of pi over 6, 30 degrees, is 1/2. And the cosine is the square root of 3 over 2. So we have some numbers there. And this is u plus iv, because w is equal to u plus iv. And now we would like to find a relationship here between u and v. And to do that, we will use the cornerstone identity of the hyperbolic functions, the hyperbolic cosine squared minus the hyperbolic sine squared is equal to 1. So this should look like, this reminds us of cosine squared plus sine squared equals 1. With the hyperbolic functions, it's a minus. So u is 1/2 cosh y, and v is root 3 over 2 sinh y. So if we just solve these for the hyperbolic functions themselves, cosh y is equal to 2u, and sinh y is equal to 2v over root 3. And we can plug those in here. Cosh squared is 4u squared, squaring the 2u. And sinh squared is 4v squared over 3. 4v squared over 3. So we get this equation in the uv plane, 4u squared minus 4/3 v squared over 3 equals 1. And this equation is a hyperbola. I missed a b there. Is a hyperbola in the uv plane. If v is equal to 0, then u is plus or minus 1/2. These are going to be the foci. No, they're vertices. of the hyperbola. The hyperbola comes in two branches. One branch is going to look like that, and the other branch is going to look like this. So we have the two branches of the hyperbola. So this is our image. And a little bit more detail here. A hyperbola has a couple of asymptotes. The curve is nestled in between these two lines. Those are asymptotes for the hyperbola if we draw it well. So let's figure out the equations of these asymptotes. We could do that right from the equation here. If u and v are very large numbers, then u squared and v squared are also very large. And even though this difference is 1, if we're talking about very large numbers, then we would say that 4u squared is approximately the same as 4v squared over 3. And this will give us the equations of these two lines if we solve for v. So v squared is equal to 3u squared, and so v is equal to plus or minus the square root of 3 times u. And those are these two lines here. This one is v equals root 3u, and this one over here going down is v equals negative root 3u. Those are the asymptotes for the hyperbola, and 1/2 and negative 1/2 are the vertices. Again, the vertices came from letting v equal 0. If v equals 0, then this equation becomes 4u squared equals 1. So u squared equals 1/4. So u is 1/2 or negative 1/2.